Hello friends, today we are going to design beams in RCDC. As you already know, we are working on the same project and I am importing same file, MDB file, and select beam. As you can see, all the levels from our model will appear here. I am selecting first slab level and click on create new project. It will take some time to import. Now our import is completed. As you can see, our beam layout, and in our left side here is beam group, beam numbers, sizes, as you can see the beams in group here are the continuous beam in continuation. As you can see on the plan also, beam in continuation. These beams are not exactly typical or same reinforcement but in continuation. So the RCDC is showing in group here. If you check the beam in continuation, it will select the beams, all beams in the continuation. It will be easy to design and detailing of the beams, add support reinforcement and the detailing some beam in continuation. So we are keeping beams in continuations so that we can easily give reinforcement or support reinforcement throughout the continuations. You can break the beams also. For that, here the beam continuum, you can break the beam if you want to break. At sometimes we break beams for convenience of reinforcement. We will select some beam, we will break this grid and keep all other grids as it is. This I am breaking this beam for only for showing you. So select the beam grid here and at the support just right click, and here is the one option is split group. When I click here, you can see the first beam is separated from this continuity. In this way you can break all these beams. Okay, I have splitted this continuation, and these beams are separated from the continuity. I will explain this effect of the breaking beam in while we are design the beam or edit the reinforcement. What will affect when we break this continuity? We will see when we give reinforcement. Now we'll go to column data. We need to import column data. Then go to setting. Here we have to change some parameters. Here the first parameter is ignore torsion. We will keep as it is. The next is ductile design. This is important for earthquake design, as we are going to design our structure as ductile, and we have selected the code here 13920 for ductility. We are selecting ductile design at all sections. Then flange beam, you can consider the flange beam, but here we are keeping as it is. We are not considering the beam as a flanged beams. Then detailing setting, you can keep as it is. It will select the diameter by itself. The next is percentage steel. You can edit minimum percentage as per formula from our code, and then maximum for beam and the nominal steel. Then you can click crack width check, but we are not clicking here. We will keep as it is. Then next is material properties. As you can see here, it will select default, but we have to change this property. Then what you need to do here is, one option is use material from properties from analysis. It has taken the properties from analysis. If you want to change, just uncheck this option and then change the grade of concrete as per your requirements. I am keeping here M25 and grade of steel Fe500, cover for beam 25 and aggregate size 25. Then rebar setting, you can select your rebar preferences or availability of your rebar. You can add or remove the diameter. We will keep as it is. Then the minimum or maximum bar sizes you can also change. The next is stirrup spacing. You can change stirrup spacing. I will keep here 100 mm minimum and maximum spacing 300. Spacing roundup, you can change spacing roundup value as per your requirement. I am keeping here 25, as it will easy to output the drawing. Then here is one option, different rebar for outer and inner stirrups. In heavy beams with multiple legs, it will consider the outer and inner rebar in different diameter. I am not checking this option. Then click on OK. Next is rebar curtailment. You can change as per the code, or we will keep as it is. The values are as per our code selected, so I am keeping this all the setting as it is. The next is detailing and drawing. In detailing and drawing, when the drawing and section, RCDC will give drawings and sections as per these settings. As you can see here, cantilever tie back length you can change as per your requirement, but we will keep as it is. The bracket length, the minimum vertical for L, you can change if you want, or your specifications. Here is secondary beam end anchorage. The next is style, rebar couplers, effective span for curtailment, center to center of the support or clear span. The next is provide curtailment from support face or support center. Mark curtailment from support, we are keeping support face. And here another option, rebar mark manager. As we have already seen in our last video, you can change the rebar mark as per your requirement. You can set the values for it, will appear in our drawings. I will show you when we export the schedule. We will keep this format and then SFR. We are not going to change here. Okay. The next is preferred rebar spacing. You can see beam width, rebar numbers, rebar less than or equal to 16, 3. These 3 numbers of bars at bottom or top in each face. If you give the value, you cannot give number of bar less than this value. So we will keep as it is. You can change this value also, but we will keep as it is. We will keep as 3. As here it's showing only one size, as we have given in our model a typical 230 beam size. If we have 300 and 400, 450 different beam sizes, it will show different rebar numbers for different values also. So we will keep as it is. Click on OK. The next is load cases and combinations. As we have already seen in our last video, we will import from our predefined load combination or exported load combinations. Click on open. You can see load combinations will also be imported from our predefined or exported load combination. Then just click on OK. Then we are done with our settings. Then click on design. It will take some time. You can see progress here. Now you can see the beam designing is completed, and here it's showing some beams are failed. The number of, here it is showing the numbers, group numbers of that beams. We will check. Now you can see the different diameter of rebar for beam in continuation. You can change. We will see one by one. First we will see failed beams. As you can see, this group is failed group. It is showing in red color. We will design this. First we will see one group and will arrange the bars reinforcements for these beams. We will check these beams in our plan. Here you can see the P1 is cantilever. As you can see here, B1 is, this is our group number, this is beam number, and here it is showing type of beam, cantilever or ductile, and here it's showing the size of beam. Here is material, and bottom, this is bottom reinforcement, left, mid, right, and this is top reinforcement, left, mid, right, and the shear at left, shear at mid, and shear at right. SFR diagonal. We will check one by one. First we will see again on the plan. As you can see, beam number 1 is cantilever, then beam number 2 and 3. We will arrange the reinforcement. First we will give the reinforcement for cantilever beam. As you can see, the bottom reinforcement as cantilever is minimum, and here this is design reinforcement at top of the cantilever. So we'll check. If you double click on this, it will show the small window for bar layers and reinforcement. Here you can see the AST also. This is AST required and this is provided. We will the RCDC showing the default bars as per the requirement of AST. It is showing 3 numbers of 25 diameter bar. So we can change or rearrange the number of bars and diameter. For this you have just check. We'll change this number first, number of bars, and then you can see here diameter. We will change diameter of bar. It will show here we will require more number, so we will check different combinations of bars. As you can see, 3 number of 16 mm and 3 number of 16 mm in second layer. So this is okay, and just click on OK. You can see the reinforcement revised appear here. Now for cantilever we are giving the top reinforcement same, so you can edit this also, or just right click on and copy reinforcement, select and paste reinforcement. It will change all the reinforcement. Then now for bottom reinforcement, as you know, for 50% of the top reinforcement we will give for cantilever. You can keep as it is or change this also. For this we will just change 3 numbers of 16 mm diameter, copy and paste. So our first beam is ready with the reinforcement. Then check the shear reinforcement, as it is showing the minimum reinforcement as shear reinforcement 8 number of bars, 2-legged stirrups at 300 center to center. You can also change these values. As you can see here, the small windows appear when you double click on this. Is the left, mid and right. This is shear area required and this is provided. You can change the legs of stirrups also. You can put the value 4-legged stirrups or 6-legged as per your requirement. As we have beam size is 230, we will check another beam for 4-legged stirrups. You cannot provide 4-legged stirrups for 3 numbers of bars, so it is not taking the 4 number. It will show the message not enough bar on the top and bottom layers. You have to give 4 number of bars to give 4-legged stirrups. So we will change the next we will change the beam in next beam or the another beams. We will change the size and check how to give 4-legged stirrups. We will just keep 2-legged stirrups. You can change here the number of bar. You can change 10 mm or 12 mm stirrup size, and the spacing here we will keep 100 as the beam is cantilever, or 150 you can keep as per your requirement, but the value maximum is, the minimum requirement is 300. You can change the value under the 300. So I am taking 100, click on OK. As you can see, our first beam is ready. Then you can see when we have changed here, it has all automatically taken the top reinforcement for the continuity. If you break, as earlier when we are breaking the continuity, I have told you that we will explain the continuity format. When we give the reinforcement at right of the B1, then left of the, when we give reinforcement at right of the beam B1, it will take the continuous reinforcement automatically at beam 2 also. Same, when we give continuous reinforcement or the support reinforcement at left of the beam 2, it will give same reinforcement to the B3 also. We will check here. We are given top reinforcement, then the beam number we will check for the beam 2. Here we will give first layer continuous, so I am changing number of bars 3, and you can see here 3 number of 16 and 3 number of 12. Here also 3 number of 16 and 3 number of 12. I am going to change here 3 number of 16. I'll just change, it's not required, it's sufficient reinforcement, but I am changing for your understanding. If I give, just see here in here, if I give 3 number of 16, then you can see this value is automatically changed here also. It will take the continuous reinforcement. For ease in detailing, you need not change every time. If you break the continuity, we will see we have already broken the beams. We will check those beams also. As you can see, same, it is easy to detail and beam reinforcement. So we'll check the bottom reinforcement also. it is okay. Here this is also okay. The number of bars, 3 number of bars continuous in one layer. The next is, here is 3 numbers and here 2 number is second layer. You can give the same number of bars throughout the beam length. Here also 316, you can keep the bottom layer same number of bars. So I'm just copying this 316 and keep here. As you can see, 316 at bottom layer, and then at bottom left support 212, and we will change. You can check here, you can check the stirrups also, 2 leg 10 mm at 100. Okay, now we have done with our first group. In this manner you can change all the beams, reinforcement of all the beams. As you can see, RCDC will give you the reinforcement, but for ease in working on site you have to give the bar numbers in continuous or the same bar numbers, or you have to rearrange these bars. As you can see here 320 and here is 316. It is difficult to work on site, so you have to provide the same number of diameter in one layer and the next in the second layer. So you have to rearrange the bar as we have done here. So same procedure for all the beams. The next we will check those beams we have broken the continuity. Beam number 45, 46, 45, 46 and 47. We will check for these 3 beams. As you can see, we will check at support first. If you check the support reinforcement, it is same almost, but here as you can see, here for beam number 46 at right support 3 number of 16 and 2 number of 12, but here at the left of the 47 you can check 3 number of 12 bars and 3 number of 12. This is because we have broken the continuity, but actually at this support same number of bars and same reinforcement should be provided. So if you break the beams, you have to change this or check these values all the time, and it will lead you to mistakes. You can break beams, but it will difficult or time consuming for design the beam. If you change here, you have to manually change here or check every time in the beam in continuation. So we have not broken continuity for all the beams. The next is we will check our failed beams. As you can see, the beam group G112, that is beam number 205 and 206 are failing. We will check on the plan also. As you can see here, these 2 beams are failing. We will check the failure diagnostic. Here this option reports failure diagnostic. You can see here the beam group number, beam number, and the top moments, bottom moments, and shears, and here the cause of failure in remarks, bending moment, detailing failure, and shear tau max. For our group number G112, the bending moment, detailing failure, that means that our beam size is not sufficient for reinforcement accommodation, so we need to revise our beam size. Then let's just right click, and here is option design. You can see in the window, you can see the beam sizes with the grades, layers and reinforcement. We will just try to increase beam width and depth. We will check with random sizes for our understanding. As you can see, the beam number and failure type, location, load combination for which the beam is failing, the bending moment, the maximum bending moment and the torsional moment. We will just keep a random value. This is not a feasible value, but for our understanding we will just pass the beam. Okay, the beam is passed for this size. We will accept it, and you can see here the revised reinforcement for our beam number 205 and 206. We will arrange this bar also. Okay, we have just arranged the reinforcement for this beam only. We can also change the second beam. Okay, we'll try for the second beam also. As you can see, we have rearranged the reinforcement, and we have just earlier said that 4-legged stirrups. You can see here the 4L means 4-legged stirrups at diameter, 8 mm diameter and 100 spacing. You can see here the legs values. We will discuss these in when we export our drawings for 4-legged stirrup. You can change diameter of these legs also. 4-legged stirrups, we will keep it as it is. As you can see, we have revised the failed beam. In this manner, you can change all the failed beams and rearrange the reinforcement for all the beams. Your design of beam will be completed. You can select one by one group and rearrange the bar size, the stirrup spacing. You will complete your beam design. Once you complete the design and reinforcement arrangement, you can export the beam schedule in the AutoCAD format also. Let's check another option here. For manual grouping, there is one option here also. You can group ungroup beams, as we have already seen in the column and footing. If you create a groups, you will reduce your schedule size or the number of sheets for your drawing. You can group the beams by the same size and the same reinforcement. You can group all the beams with same specifications. Then here is also the ignoring option. If you want to ignore some beams, suppose we will select this beam, I want to ignore this beam, you can just right click on ignore or modify and ignore beam. Okay, 1 second. Beam number 19, you have to put the number of beam. Just check beam number 19. As you can see, the beam number 90 is ignored. Then next is change. You can change the beam data also, the numbers in the data. The next, edit description of the beam prefix. You can change this also. Then once you complete all your design, editing and rearranging, you can go to schedule. Here one is, we will just check a design calculation for a single beam. We have design group number 1, so we will just check the design calculation. Before we go to schedule, we will just check the design calculation. As you can see, this file is open and you can check the design here. The group number, beam number and the beam properties, the combination for which the beam is designed, the moment, the value of torsional moment, shear reinforcement percentage, all you can check here in detailed calculation for the beam design. Or you can check the summary as we have already seen in our last video. Then next is beam schedule. Here for beam schedule there are two options, two format. One is type 1 and 2. We will check both the formats. And here the display style, all beams ungroup and group. We will keep ungroup and we will check the first format first. Click on OK. You can see the schedule in the first format. In the first format you can see beam number, beam sizes, and the reinforcement showing here is at we have designed as left, mid and right, same as top for left, mid and right, and the stirrups format, and then shear, SFR, diagonal reinforcement and remark. As the format we have designed here, it is showing as it is. You can save this file. I will save this file. You can save this file in AutoCAD format. Then we will check the next type also. In this type The reinforcement only change is the reinforcement showing is in the format of straight and curtailment. As you can see, there is no left, mid and right option, only straight reinforcement, curtail reinforcement, and here extra left, extra right. You can take the output as per your requirement or your specification, as you want, which type you are wanting to select. You can take the format. The next is elevation and section. We will just check the cross sections. As you can see, the section, if you want the beam sections, you can see beam number 1, 2 and 3. It will give you all the details, the dimension, reinforcement and all the details for your beams. You can create the section for all the beams. The cross section of beam 1, 2 at different locations, it will show you. You can create this section for all the beams if you want. You can also save this file also. I will just save section. And we have forgotten to save the layout. You have to save this layout in the format of AutoCAD. Now we will check our output files. As you can see, the beam layout plan you can arrange in your format. Then the beam schedule, you can arrange this schedule as per your format. All the beams are given by RCDC in the format of our DXA file. You can rearrange and prepare the drawings. In this way, you can design any level of your model or your building one by one and create the drawings. Please comment if you want any information, or if we left some points. If you comment, I will clear all the points from column, footing and beam design in our next video. Please comment. Thank you.